Today we're going to finish up Chapter 4, and we're going to do that by looking at compounds that contain ions. Remember that ions from the last lecture are metals and nonmetals that lose or gain electrons to form a positive or a negative charge, and in doing so form a compound. So ions combine to form ionic compounds, just like sodium chloride. Ionic compounds tend to have a high melting point. They conduct electricity if they're melted or if they're dissolved in water. All right. The big thing about ionic compounds is that when you have elements that react together to form an ionic compound, they become electrically neutral. What does it mean to be neutral? Neutral means to have no charge whatsoever. So they lose or gain electrons in a manner so that the compound becomes neutral. The charges on the anions and the cations must sum to zero. Okay, so I just wanted to bring this picture up. You already have yours marked. It is super important that you have this periodic table in front of you. Well, of course, not this one, but the one that you have, because you've already marked some of the ions that they form. So remember that this first column, the alkali metals, tend to form the +1 charge when they form a reaction and form a compound. And the alkaline earth metals have a +2 charge. We talked about aluminum always having the +3 charge. Fluorine has a -1 charge. That whole group, the halogens. Oxygen's group tends to have a -2 charge. And this next group over with nitrogen tends to have a -3 charge. So transition metals, on the other hand, those can vary as far as what their charges can be. Remember that silver, we can rely on it to always form a +1, and zinc to form a +2. So you need to keep that in mind and make sure your periodic table is in front of you when you do these problems. So let's go ahead and go on to the next example. All right, so how are we going to write them? What are the rules? There has to be rules. So formulas for ionic compounds. You're going to write the cation, and you're going to remember that the cation is the plus sign, right? It has the T in it, so that's the one that's going to lose electrons and become positive. And you're always going to write the cation's element symbol first, and the anion is going to be second. So here in this example, we have magnesium. Magnesium is in the alkaline earth metals. It tends to lose 2 electrons. So in order for it to react with chlorine correctly, chlorine is in the halogens group, group 7, and if you look at the top of your periodic table where you have that marked, you'll notice that they form a -1 ion, which means that they gain an electron. Well, if magnesium is +2 and chlorine is -1, they obviously are not going to go together 1 to 1. They can't, because +2 minus 1 is +1. We want the overall charge to be 0. So it takes 2 chlorine ions to satisfy the charge of the magnesium ion. So the magnesium is going to be very generous and give up 2 of its electrons, 1 going to this chlorine and 1 going to this chlorine. So then we put it in MgCl2 form. We followed the rules. Our cation is first because it's the +2. Chlorine is the anion, and it goes second. You always have to make sure the sum is 0. Let's look at the concept check. It says a compound contains an unknown ion X and has the formula XCl2. Ion X contains 20 electrons. What's its identity? So this is kind of one of those where you're working backward again. So chlorine, we remember, has a -1 charge. And that's because it's in the group 7 or 17, depending on how you look at your periodic table, and it has a -1 charge for the halogens. We have 2 of those. That means that this side right here, this anion portion, has a -2 charge. So what must this element have? There's only one of that cation. So what charge must it be to balance off this -2? Well, we have to have a +2 to balance these out because we want our overall charge to be 0. So if I want this side to be +2, what must the charge on this X element be in order to make this side +2? 1 times what is 2? And the answer is 2. So we know that if we looked at X by itself in ion form, it would look like that. says that ion X contains 20 electrons. If it contained 20 electrons, how many electrons did it contain before it reacted? Well, it gave up 2, so we're going to add those 2 back in. So it had 22 electrons. That means that it also had 22 protons. And take a look here at our periodic table, and go to number 22, and it looks like it's titanium. So titanium with a +2 charge is what the X should have been. Now I know this seems probably a little more complicated than what some of your problems are going to be. Let's do an example of one of your problems. All right, this says a member of the alkaline earth metal family whose most stable ion contains 36 electrons forms a compound with bromine. What is the correct formula for this compound? All right, so it had 36 electrons, and alkaline earth metals, that's group 2. So group 2 tends to form a +2 charge, just like the magnesium did. Now that I managed to get the lights back on, we'll finish. So this is X going to be +2 because it's the alkaline earth metals, and it had 36 electrons. If it had 36 electrons and it lost 2 of them, that means that it must have had 38 electrons total, which means that it also had 38 protons to start. Well, that's how many it has all the time, but it has 38 electrons. So it has 38 protons. I look for element number 38, and I see that it's strontium, which is Sr, and it wants to know which one of these is going to be the one that is the answer for bromine. And let's just double check our answer, because the only Sr I have is SrBr2. Remember that Sr forms a +2 charge, bromine forms a -1 charge, and this is where the simple algebra kicks in. My overall charge has got to be 0. Obviously 2 minus 1 is not 0, so you have to say what's the smallest number they both go into. The answer is 2. If this side is +2, then this side over here needs to be -2, so I'm going to multiply that times 2. Now 2 minus 2 is 0, but that also means that I have to have 2 bromine. So I would write it SrBr2. Okay, so I'm looking at your textbook right now, and I'm looking at your textbook right now, so we're going to do a couple of examples so that you don't get confused about what your job is in this assignment. So you're going to be doing 79 through 84, and then you're going to flip over on page 113 and do number 108. And you can work with your lab partner. Just remember to make sure it's your responsibility, lab partners, as a pair, to help the other one understand what's going on with these. So since you already have 84 in the back to look at for your answers, I'm going to go ahead and do, let's do A and C, just to show you how to do the work, and then you can handle the rest of them on your own. So let's look at number 84, I'm sorry, because it's in the back, A. And the element is an ion of iodine. It says for each of the following negative ions, use the concept that a chemical compound must have a net charge of 0, and predict the formula of the simple compounds that the negative ions would form with, and then it lists cesium, and cesium is going to form a +1 charge with barium, and barium is going to form a +2 charge, and the third one is aluminum, and that's going to form a +3 charge. Now A is relatively simple because we're dealing with 1. This is a -1. So if we put iodine with cesium with +1 and -1, well, +1, -1, overall charge is 0, so you're going to have this one as CSI. One of my favorite shows ever, but anyway, so CSI. On the other hand, barium has a +2 charge, and the iodine has a -1 charge. So it's simple math. What number do we have to have of iodine in order to combine with the barium? This is similar to the one that we did earlier, and that's going to be barium, one of those, and if you have to have 2 iodine, because if you don't, your overall charge isn't 0. So if I have 2 iodine, that makes this side -2, positive 2 and negative 2 with overall charge of 0. The last one is aluminum. Aluminum has a plus 3 charge, so in order to cancel those out and make an overall charge of 0, I need to have a negative 3. That means I need to have 3 iodine, so it's Al(I)3. One thing I want to bring up also is notice how when we write it as the compound, you don't see the plus and negative signs anymore. Those don't belong in there anymore because this is a compound held together by an ionic bond due to a transfer of electrons. So this plus minus stuff doesn't go on anymore, so don't make the mistake of adding those in. Let's look at 84C, I believe it is, and it's phosphorus, and it has a minus 3 charge, and we're going to put it with each one of the ones up above. So cesium plus, and we add phosphorus minus 3, and I hope that you can see, just due to simple math, that if we have a minus 3 and a plus 1, that would give us a minus 2. So how many cesium is it going to take to cancel out this minus 3? Well, it's going to take 3 of those to have an overall charge of positive 3. So we're going to write it as Cs subscript 3, capital P. Barium is a little different. It's plus 2. Phosphorus is minus 3. So you have to stop and say, okay, what's the smallest number they're both going to? 6, of course. So we're going to multiply them times something that's going to give them a 6. It's going to make this side negative 6. It's going to make this side positive 6. So 2 times what number is 6? That's 3. Negative 3 times what number is negative 6? That's 2. So it's going to be Ba subscript 3, P subscript 2. It's just simple math, so don't let it throw you for a loop at all. Just think about the smallest number that they both go into. Let's try aluminum. This one's really easy to see. Aluminum plus 3. Phosphorus has a minus 3 charge. Of course, they're going to cancel out 1 to 1. So your answer is AlP out. So there's how to do the problems. Work with your lab partner. Make sure your lab partner knows what you're doing. You will have a test over Chapter 4 this week. So make sure you do your vocab when you're finished.